All right, in this example, I want to find the antiderivative of t times e to the t squared plus 1. All right. Well, okay, I'm kind of seeing an inside function, right? Because this t squared plus 1 is inside the exponential function. And then I've got this multiplier of t. I'm actually going to rewrite this just so you can see it a little better. I've got e to the t squared plus 1, and then times t dt. All right, I can rewrite it that way. Now notice that the derivative of t squared plus 1 is 2t, not t, but that's okay. We can deal with that. I'm still going to let w be t squared plus 1. All right, so then dw, just taking the derivative of both sides, I get dw is equal to 2t dt. All right, but you can see I need to do a substitution. I need to do a substitution with t dt, not 2t dt. So here's what we're going to do. We're just going to divide both sides by 2, or multiply both sides by 1/2. So I can actually write this as 1/2 dw is equal to t dt. So now I can make a substitution for t dt, but it's going to be 1/2 dw. All right, so let's do that substitution. We get the integral of e to the w, okay, replacing t squared plus 1 with w. And then I'm going to replace t dt with 1/2 dw. Okay, so I can actually pull this constant 1/2 out, right? I know my properties of antiderivatives, and I know I can just pull that 1/2 out and get the integral of e to the w dw. Okay, and I know that the antiderivative of e to the w is just e to the w, right? So this is equal to 1/2 e to the w plus c, right? So last thing I need to do then is just to substitute t squared plus 1 in for w, so I can write my answer in terms of t. So e to the t squared plus 1 plus c is my final answer. That's the antiderivative of this function. All right, I'll meet you in the next video for the next example.